Hello and welcome to the demo of UCR Star on Raster. So this is the current product we have. It's called UCR Star. It is a vector data visualization platform. Vector data is typically a single dimension. I mean, not a single, it can be two dimensions as well. So it's basically a data point that can be a point, line string, or a polygon in the map. There are different formats in the OGC standard. That's the Open Geospatial Consortium. They have certain standards, but it's basically having visual, different shapes that are typically hollow in nature, or it's like more like a boundary on the map itself. So we have this platform already for vector data, and we have a lot of data sets that we support, right? And this is what we have, and the features include like you can zoom into any region that you want, and you can choose to download the data that's present only within that region, because geospatial data can be in the higher order in terms of space. So you don't want a lot of data. So only in the region of interest, you can zoom in and choose to download the data in any format. We support multiple formats at the moment. So this is what we have, and it takes some time, and you're able to download the files, and then you can visualize it in some explorer. Here we've used QGIS, and as you can see that we've downloaded quite some point datas, right? And we're able to visualize it, right? We can also click it and get some information. That's something we have. So what we have improved now is we've tried to build the support for raster data. Raster data is essentially images, satellite imagery of any point on Earth, not just a point. It typically is a grid or a specific rectangular or a square dimension on Earth. It is a raster image or the satellite image of that region. As you can, already understand, the raster images are higher in terms of the space occupied and the memory used. So it's going to be more intensive, both computer intensive and memory intensive. And our approach is to extend what we have on UCR Star. This is something called as pyramid visualization of images. This is what is used by, Google Maps and various other map visualization applications. And we have extended the capability for satellite images as well. So that's let me start the server in the background. So what we essentially try to achieve is we have a data set that we acquired from some satellite imagery source, right? And we pre-run some commands. This is like an optimization that we do. And up to certain zoom levels, we generate PNG tiles for that, right? It follows the format ZXY, tile ZXY, where Z is the zoom level, as you can see. Currently, I'm highlighting zoom level 7, and X and Y are the XY coordinates on where to put the a tile on in terms of the map. So the map will be divided like a grid, and as you zoom in, so initially it's just one tile. That's the topmost part of the pyramid. But as you zoom in further and further, the tile breaks down in powers of 4 or exponents of 4, and you get like one tile to four tile, 4 to 16, so on and so forth. So as you can know, like as you can see, it grows exponentially. At some point, it's going to grow really fast. So you don't want to be pre-generating a lot of zoom levels. So I've chosen zoom level 7 to be the threshold, until which you can use the ready-made tiles that we've made. It takes a few minutes to generate these tiles, and this is done as a cron job in the back end of the server. So as you can see, as we're zooming in, we're able to get a better resolution of the tile. That is the single biggest expectation in terms of visualization and exploration of satellite imagery. You need to be able to process the tiles efficiently. We've used a extended version of Spark that's called Beast for geospatial analytics in Spark, and distributed computing principles to be able to do this process of pre-generation of these tiles more efficiently. The details are included in the paper that's attached. Right now, what we have is the PNG images that are generated after the process of several minutes. This will be done like a cron job as soon as we get the data source from the satellite itself. And as you can see that these PNG tiles are being rendered in like few milliseconds, and we have quite a bit of zoomed PNG tiles that are available in the ZXY format. What you can currently see on screen is the millisecond retrieval of pixels. So any pixel that you click, we need to be able to go through the actual, TIFF file or the satellite imagery file. This is few in the order of few gigabytes in nature, and there are a bunch of these files. We need to be able to process them efficiently, find the right file, and then extract the right information. And that's exactly what we do. We've also included a feature where you can download all the image sources, the original sources, not the PNG files. So the PNG files are adjusted in resolution as you zoom in or zoom out, but the original data sources are of a particular resolution depending on what satellite and what product you're using. So here you can, zoom into a region, and whatever tiles that are present within that region, you will be able to download that using the download within the selected region. So I zoomed into a region and I downloaded it. And right now I'm just visualizing it in another Explorer. So as you can see, this is somewhere around Nashville, and there are a few tiles. So I'm just comparing both. So this is exactly how it looks in my application versus another data exploratory application. You can see that even QGIS takes a long time, and that's because it uses a single node for processing, whereas we use Spark internally and try to do distributed computing so that we can do it faster. Thank you.